All right, we're going to take a look at a system of linear relations question. This one involves three variables here. Let's take a look. The ritual candle ceremony. So in this question here, we have during the ceremony, a priest lights 3 candles. So we have 3 candles. And it says here that there are different lengths. We have a red candle, we have a white candle, and a blue candle. I know the red is 15 inches. That's told to us. The white is 10, and the blue is 20. Let's go ahead and try to label this. So I've got a red candle, to which they say the red candle is 15 inches. I then have a white candle, which is 10 inches. And then lastly, we have a blue candle, which is 20 inches. So we've got this set up here. Now let's see what else is happening. Each burns at its own constant rate, so they could be going at different rates here. It says after 4 hours, the remaining length of the red candle and the white candle are equal. So let's take a look at that. So after 4 hours, and again, if you want to try the question yourself, pause it, work through it, you can do that as well. So it says after 4 hours, the remaining length of the red candle and white candle are equal. To start this off, I'm going to let R equal the burn rate of our red candle. And then we're going to do the same for W and B, so burn rate. So now that I have my variables defined here, R, W, and B are going to be their respective burn rates of the red, white, and blue candle. By the way, the rate of the measurement here, this would be measured in inches per hour. That will be your units of measurement for this rate of change, for these rates of change here. Now, the sentence I've highlighted in brown here says, after 4 hours, the remaining lengths of the red and white candle are equal. Well, initially, the red candle has a height of 15 inches. But I know that after every successive hour, it's going to decrease by a rate of R, right? This is the burn rate per number of inches that are taken off per hour. So if this happens for 4 hours, you multiply by R, right? Because this is going to be the rate of change. It's going to decrease, right? So if R, this is 4 hours, if this is decreasing, let's say, 1 inch per hour, it's going to be 15 minus 4 times 1. If this is decreasing by 2 inches per hour, it would be 15 minus 4 times 2, etc. So it says after 4 hours, the main lengths of the red and white candle are equal. So therefore, I can set this equal to 10 minus same time, but the burn rate is different. So there's our first equation, used with the sort of the brown equation. I've highlighted in brown. That would be this one. Let's take a look at another one. It says now after 6 hours, the remaining length of the blue candle is equal to the sum of the remaining lengths of the red and white candles. So therefore, we have another equation. So the second equation is after 6 hours, the length of the blue candle. Well, the blue candle is 20 inches. So after 6 hours times its burn rate, it is equal to the sum of the remaining lengths of the red candle. That'll be 15 minus 6R, right? We're doing 6 hours now, plus 10 minus 4, oops, sorry, not 4, almost did it, 6W for 6 hours. And that represents equation 2, right? The length of the blue candle after 6 hours is the sum of the lengths of the red and white candle after 6 hours. And taking a look here at the last sentence, if the red candle burns completely in 10 hours, find the burn rates and the time for each candle to burn. So they tell me in the neon question, what I've highlighted neon here, the red candle burns in 10 hours. Well, if the red candle burns in 10 hours, that means that per hour, which is it's the burn rate of R, that's its burn rate per hour, will be 15 divided by 10. And if I do that, this is going to be 3 over 2, which is 1.5 inches an hour. So we actually know the value of R right away. Before the question even starts, I know that R equals 1.5 inches per hour. So let's go ahead and take a look at what we have here. So now that I have that value here, I know that my R is 1.5 inches per hour. You can make a quick observation. I could sub this into equation 1, and therefore I have 15 minus 4 times 1.5 is 10 minus 4W, in which case I get 15 minus, in this case here, 6 equals 10 minus 4W. And we can kind of solve for W just by the fact that we had the value of R. I can sub into equation 1 and solve for W here. In which case here I get 9 equals 10 minus 4W. 4W equals 1 in this case, and W equals 1 over 4, which is 0.25. So now I know W is 0.25. And then lastly, I can solve for B here, subbing this into equation 2. So if I go to equation 2, I have 20 minus 6B equals 15 minus 6. But I know the burn rate of R is 1.5. And I also know the burn rate of W is 0.25. So I end up getting here 20 minus 6B is 15 minus, this is going to be 9. 50% more than 6 is going to be 9, plus 10. And then in this case here, this will end up being equal to minus 1.5. 25% of 6 is going to give us 1.5. So continuing this up here, I get 20 minus 6B equals, so adding this all together here, 15, let's do 15 minus 9 is going to give me 16, and then 16 minus 1.5 is 14.5. So going ahead and solving here, I get negative 6B equals negative 5.5, and solving for B, I end up getting 0.92 approximately for this one here. All right, so putting this all together here, we actually have the burn rate. I know the burn rate of this candle is 1.5 inches an hour. I know the burn rate of the white candle is 0.25 inches an hour. And lastly, the burn rate of the blue candle is approximately 0.92 inches per hour. And then the question goes on and asks you what time does it take for each one to burn. You just divide these out, right? So if I take the length divided by the burn rate, you can see here if I take 15 divided by 1.5, I end up getting 10 hours for the red candle, and 10 divided by 0.25. The white candle is going to take us 40 hours. And lastly, 20 divided by approximately 0.92, we get approximately 21.7 hours for the blue candle. All right, just a quick little question, solving systems of linear equations just when you have 3 variables. This one comes out more or less like a 2-variable question because they kind of directly give you one of the rates of change, but interesting question nonetheless. Thank you.